Welcome back to another episode of the Integrate Intelligently podcast. I'm your host, Jeff Brickler, again accompanied by my brother and CEO of CAD Talk Software, Scott Brickler. Today we're talking about data as an asset and the importance of data in manufacturing. So this is an exciting topic. Scott, I am quite the distance away from home. I'm here in Sweden at a local conference, my first time in Stockholm. So it's in the evening now and getting ready for my return home. Looks like you're still in the home office, so that I'm feeling a bit jealous right now.
I bet. I know that the travel. Well, you love Europe though, so I'm not feeling too bad for you because you always love going to Europe.
Must admit, since I first went to Europe as a student in 1998 when I was an undergraduate and studying in Italy. That first time was like gave me the bug, and then I just like to come back and visit new countries and see new things. But if I'm to admit, the allure of flying overseas is not quite that object's not quite as shiny as it used to be.
No, sometime on this podcast we're gonna have to tell the story about us going to see the Pope on
yes, that would be an interesting story.
Getting blessed by the Pope and all that. It's a heck of a story.
Yes, no, yes. Our first time in Europe. Yeah, absolutely. So
yeah, it's a great one.
So Scott, today we're talking. I'm at a conference, a user group conference, and what's interesting is that today's topic is rather timely because we were talking about AI and data. And so today I think is really timely in the sense that today we're talking about data as an asset and the how important that is for modern manufacturing. So a bit of a shift, I think, for manufacturing to think about their data as an asset, not just their IP, but also their data as an asset rather than their designs and their products that they make and sell.
Mm-hmm. Yeah, that's a wild one. I remember it extends even past manufacturing. I think that's going to be the future. I mean, that's the future. That's the way it is today. I mean, it's like I think every industry is going to have this idea where the data is going to be worth more. It's going to be the biggest asset they've got. It's hard to obviously measure that, compared to the business itself and what they do and stuff. I mean, there's actually a story about this. Let's go one side. Is like I was actually watching some stuff the other day on some videos, and they're talking about that one of the limitations of the models, like AI models, is they just don't have enough data to train it. And that's actually the thing that they're actually running out of data. Like it's crunched the entire internet, and that wasn't enough. Just to give you the idea of that. So like the idea of not having enough data is a huge problem. There's actually a story from years ago when I worked in industry in manufacturing. It was kind of a precursor to this. I didn't realize how right I was. I mean, of course, I love being right. Of course, we all do. But how on point I was at that time and didn't even know it, which was we were talking about we were implementing an ERP. We were actually running N4 at the time or whatever the ERP was, and it was Sightline. And they kept going around the system at night to get these jobs done. And they wouldn't clock any of the jobs. They wouldn't do the transactions. They would just like kind of do these like on the night shift, would just go make parts and put them on machines because we need to ship machines to make money, which is completely valid, right? I mean, that's a totally valid kind of idea of what you're doing, in order to ship business and do the core function of the company. But and I remember getting in this debate, and I understood why they did what they did, but I was getting this debate because I was, of course, on the side of the team who actually was trying to get the ERP system running, right, and getting all the systems in place and all this kind of stuff. And I remember having this debate with the engineering, with the shop manager about this, and I said, and he's like, "What does it matter?" He's like, "Well, I need to get stuff shipped so we can make money." I'm like, "Totally understand." I said, "But there's a point. We invested in these systems in order to have data to which to run the business." And if we bypass this, we compromise that data, it doesn't have the value that we were looking for. So we could say that if your way is actually the best way of doing it, and it actually serves the purpose of the company the best, based on everybody's decision, like we all decided to buy the system and all this stuff, then we should just do it your way all the time.
Right.
Just compromise the data all the time because it's actually going to, then at least we're not trying to make the data half right. We're spending a lot of money to make the data not so good. Or we can just do it right, have a consistent process where the data is good and we get the value of our investment. Or we just don't. And then at least we can do it fast every time.
Right.
So this idea of kind of half doing it was like, doesn't make any sense, right? So, and it was the idea that like, and I said, I actually said this to them. I said, the data is actually worth more than the thing that you're trying to do in a lot of ways. And they thought it was like crazy to say that. It's just absolutely bonkers. Like, you're out of your mind. Like, I need to ship this $1 million machine. You're telling me these transactions matter to me that much? And I'm like, in the aggregate, it does.
Right.
Because those insights could save you millions in the future, just on the cumulative effect of all of those things, right? So, especially in a world today driven by these AI, that's the whole thing. So, like, of course, it took 30 years to prove that to be true, or 25 years, whatever that is now. But it's true. That's what's kind of happening right now.
I think it was true then as it is now, and I don't think it took 25 years or 30 years to prove it. I think it makes it much more obvious now, right? It's like, now that you can interact with ChatGPT or you look at large language models, again, that's just one AI, right? Generative AI and large language models is just one type of AI. That was something that came up today and at the conference, is that, just one type of AI, and that now it makes it very obvious for people who are like, oh, now they get it, right? Because now you have this chat bot that's using all that data. Now it makes sense. Like, oh, yes, now I see why. But then I think for you who understood ERP and could say we could get reports and good insights from here, to most people that was maybe too esoteric, too like high-minded, like too intellectual maybe to even see it. Where now it's like, oh yeah, I can just chat in this thing and it'll give me an answer back.
Mm-hmm. Yeah, it's the whole concept that like that cumulative data set is being used to drive all of this innovation and productivity. People just didn't see it. I mean, you could see like the preliminary idea of that, like you said, like I could pull a report and the court's like, well, who cares if the report's 2% off, right? It doesn't like, it's not, if it like, it's worth it to ship. It's worth that sacrifice to ship the machine faster to get the revenue. I get it. I mean, totally understand the argument. And it's like, in that moment, it seems very true. It's like, it's hard to argue that, but at the same time, it's like, it's like, we have that kind of, there's some cases internally where we have that, where we debate about like, sometimes it's harder to do something, but like the long-term benefit of it is there, right? Like, like story settings and things like that we've talked about in the past. And it's just hard when you're like under the gun trying to get something done to really take the fact that like, no, the accuracy of this data is gonna pay dividends in the future, and really looking at that as being the asset, because it's and I think everybody thought that was just a byproduct of what you did every day. The asset was the thing that you're making, but it's actually the whole thing now. All of the data and the thing you built and how you went about doing it and the things that you learned and all that stuff becomes this asset that's truly your business. It's like people think about like as a software company or even as a manufacturing company. I say this too. Somebody could steal your designs, take your CAD models, and they still can't repeat your business because they don't have the entire business. They don't have everything that you have to do it. Now they might be able to sell parts and stuff like that. It doesn't mean it wouldn't hurt, but they can't. Like the same thing with source code. Somebody can steal your entire source code and still not replicate your business. So what is actually your business at that point? It's all of that and the data.
Yeah. So to your point, I think that it is more than just the source code or just the design. It's more than that. It's correct. Yeah. Now, people, of course, get those, and that's a huge leg up, right? They can't repeat it. But to your point, it's not just as simple as taking the code or taking the plans and just making the business. It's not just that. You have everything else involved too. That's exactly right. And I think every company, it's just human nature, right? Like, I'm trying to get something done, and then the desire is to finish it, right? Get it off your plate. And so if I can, it's hard to discipline yourself. It's like, no, I got to collect this information because it's valuable, because you don't see it as dollars. You don't see it as like setting dollars on fire, right? If it was, $100 bills taped to it and you're like, I don't need those, just throw them off. Completely, which is kind of what the data is, right? It's like they're dollar bills or some kind of currency in the data. So when you're bypassing that or you're skipping it or you're not doing it, you're like, you're just that, you're throwing it away.
And any given one is I'm thinking about the Superman 3 analogy with the micro pennies and stuff. Like any given thing with like it's probably not, but the aggregate of it all, the accumulation of that data over time ends up being a very big number. To appease the audience who's our age, you probably watched Superman 3 with like Richard Pryor, where he like wrote this program that would like skim off the partial pennies on transactions, and he thought it was going to get him, 100,000. I think it was also an Office Space. It did a similar thing in Office Space.
Yeah, it totally is.
Because Office Space is referencing Superman 3. They're actually talking about Superman. That's pretty funny.
Right.
And then like the guy comes next day with a Ferrari. He's like, I wonder who did this. And he comes in with a Ferrari and stuff. So I love that. But it's the idea of that, like that little bit over, extended over a long period of time, that is huge, right? So the data, when you start thinking about compounding data that's not quite right over huge expansions, is just an amazing. It could cost millions, millions and millions. You don't really know, and that's the part that like shows that like the value of that data is so important. There were actually something similar to that I was worried about. They're talking about like software developers being replaced by the by code, and like all the code being written now by them. And there was actually a short that I watched the other day. So it just kind of proves this point a little bit, is that the guy was like, well, I don't really worry about, not the best software developers won't be replaced, because that code, the LLMs were trained on the mediocre code.
They were trying on the crappy code.
I was like, it's true. And like, these huge code bases all over the internet with like mediocre code. And so the best that the model can do is be mediocre.
Yeah.
Which is
Exactly. They weren't trained on the best code necessarily, right?
Yeah, they were trained on all the code, which all the code is by definition average.
Yeah, exactly. I mean, you got that much. It's just that's exactly right. So I think that's a good point. There's like those LLMs. What will they produce? PhD quality results, or will it produce average results?
Now, if your data is PhD level, and the rest of the world's data is mediocre, you have an advantage.
Yes.
Once again, so see what I'm saying here? Like, yes. So the quality of your data just gets like, it's all relative to what else is out there. And the rest of the world is dealing with the general LLMs, the general AI that's trained on average.
Right. Yeah. That's a good analogy. Is that it's a good analogy? Like the quality of that data matters, and if it's trained on that, if its quality is poor, you're going to be average. Quality is really good, you're going to be above average. It's going to be PhD level, because you put PhD level data in it, right? It's like anything else. It's like what kind of, like if you're reading a book about something, right? If it's a book geared towards like average people, like an average, the average reader, versus a book geared towards like an expert in that field, different level of data, different training model.
Yeah, absolutely. So yeah, I think more and more it's probably more obvious today than it was back in the late 90s or early 2000s that the data, how important it actually is. It's just people can connect the dots a lot better than they used to be able to.
Right. It's much more obvious to see than it was then, because like I said, but then it's like where you had to have a report, or you had to be on that side of it, and only in like financials or someone in management would be able to see those reports and aggregate all this data together and then make a decision, right? Say, oh, based upon this data. But if you're a regular person, you're not seeing any of that. And so to you, it's like, oh, what's the value in this? I can't see any, I'm not getting any value out of this. Now someone else is, but now with, like you said, large language models, you go, oh, because now you think, oh, if I had an LLM, if I had a large language model and it was trained on all this data, now I can see some value because I have something to compare it to. Mm-hmm. You interact with every day, or you could interact with every day.
And I think the way I look at it, like this super simplistic way I look at all these things is like, these things are just huge correlation machines. It's so it's all about statistics, right? Like even like large language models or more general machine learning, which is like, you can apply that to data as well. All they are is they're trying to find patterns, and they actually set the things up like, it gets technical, but they use like vectors and space. That's why they use GPUs and stuff. So it's all about like figuring out where the next letter is, or making predictions on associated data. And the more data you have, the better it gets at predicting, because those things have patterns to them. So it's a pattern recognition machine, or correlation machine. And like, once again, it's just running out of data. And the more data that it has, the better it is at predicting things. The better it is at figuring these things out and stuff. So it's just, the thing I think is fascinating about it is it really works like a little bit like humans do on a very rudimentary scale. We learn things, we catalog those memories. We experience something new. It's closer to that memory that we've had in the past, and we recall similar reactions to it. It's very similar to like how we think, which allows you to think, which allows you to me, that fact that it does do that, it allows you to predict a little bit more of kind of like what it's possible to do if that was just turned up even more. And imagine if you could remember everything that's ever happened to you down to the finest detail, and you could access it at any time and call upon that to do what you wanted to do. How valuable would all the memories be?
That'd be the most important thing.
And if I could do that with every human being that ever lived and access all their memories, and what would that produce, right? So that's the kind of extraction you can go with this, right? But then, and the reason I think it goes to kind of circle back to the idea that data being the biggest asset is that here's what's going to happen is that not everyone will have access to all the same data.
Yes, no, that's right.
So the fact that like as a company, I can own that data set that's better than my competitor's data set and act upon that data set will become the competitive advantage for the future.
Yes, because I had a better operations. I collected the data. I cleansed. I did a better job managing that process. And so now I have better insights from my data set because I have more of it, higher quality, better processes that allowed me to get that data.
And it just starts compounding. Right. And so it's like the same as like compound interest, right? You get better, you give it better data, it gives you better insights, you make better changes, you move faster.
Yeah, you get better. Yeah, exactly. It's kind of exponential. Like I got good data, I get good data out, make better decisions, adjust, get better, and it just keeps getting better and better. It's like that kind of what do they call that? Reinforcement learning. Yeah.
Or having a big pile in poker.
Right.
Yeah, because whoever has a big pile gets to kind of bully everybody else who has a small pile, right? And he'd say you're able to take more risk, you're able to do more things because you have leverage. And it's just like kind of synced up the thing because you have the best data, and the best data keeps producing better results and gives you more flexibility, more things to work. It's just like I think people really underestimate like the value of that once it starts working.
Yes, yeah, I think you're right. So what kind of data do you imagine manufacturing companies would have, and where would that data be?
Well, I think you have a lot of it's going to be in these systems that we work with. I mean, you have all the design data being in the design systems, right? You have all the manufacturing data being in the ERP systems. All the stuff is there. It's like until recently, a lot of this stuff is just being pulled out as like reports so humans can interpret them and make decisions about what we should do. And but it's still all there. It's all kind of, but really the idea is it really gets interesting when you can start getting the software to then pull the data and then get insights itself and start seeing those patterns. Because I think it's a better pattern recognition machine than we are in a lot of ways. It can look at more stuff, right? It's hard for us as humans to consume that much stuff. So that's where it's going to be. So it's all in these systems that already have. It just has to be positioned in a way that they can consume it and get the insights and be able to pick up on those patterns. And you have to, obviously with anything, you can't just tell it to go crazy and it'll correlate anything to anything else, right? You can't say like, who won the Super Bowl affects my manufacturing line. It doesn't, that would be crazy, right? So you have to kind of use logic or kind of normal, what makes sense in the world type stuff. But other than that, I mean, the data is there. It's in these systems that we already work with.
Right.
Yeah.
Yeah. From design standpoint, right. They have their CAD, their PDM or PLM, and they have revisions tracking in those systems, and then they can see all the changes at each level. And so they have all the data, right. And all the metadata about those and the structure of the parts and how they're associated. And then in the manufacturing, right, they have the bills of material and all the characteristics and attributes about that part, part numbers, descriptions, type of part it is, how the parts are associated and how many there are, and what other documents, because you can use documents in large language models, right? Look at the documents and the models themselves and see models with the drawings themselves and see how those are interpreted and all of that information. That's just what we do, right? The things that we touch. Imagine like in ERP with all the financials and the transactions, both the manufacturing transactions, but also financial transactions, your CRM, like all of that data can be used to make better decisions and it's unique to you, right? To you, as you said, it's unique to you. And the better that is, the better that data will provide insights for you through the any kind of AI that you have.
Well, you think about all the sensors too. Like it's interesting about manufacturing. My daughter is getting ready to go to college. There's Avery's going to college for medical stuff, right? So she's headed up to Seton Hall and stuff. And Now I think about this, the difference between like where we come from in engineering and manufacturing compared to medical industry. Like medical industry's come a long way, but like something that we have in manufacturing that we always take for granted is the ability to measure everything. We have sensors on machines that can measure temperature, speed, everything you'd want to do in an engineering. Think about a mechanical thing. We actually have a way to measure it everywhere, right? It may not be worth measuring, but we can do it, right? I mean, everything. We are just now getting to the point where we can measure stuff in the body at even like a fraction of that specificity, right? Like that. And so, from a manufacturing standpoint, we have so much more information,
Right.
to work with, and then the fact that you have that, and then you can use it to do it, like it's a cool place because it's all open to us. It's all there, you know.
I think what you're pointing to is like, I mean, we have the human generated data in manufacturing, which is people's like designs and their IP, right? Their mental, and then of course the data they capture through humans, right? Through manufacturing. So, hey, how did this go? We transacted against it. We used this much material, or hey, we received this order. We did these accounting procedures. All of those things we capture them in our systems through manual. But you're also talking, I think, a bit about like IoT, which is like these sensors and all of this other data that we measure in manufacturing of run rates and how much we're and whether we can do predictive maintenance and seeing how long these sensors are measuring the heat or the sound or all these other things, and that's feeding into the systems as well, so we can get that. So to your point, it sounded like you were saying that like in manufacturing, with all those sensors and IoT and all that data gathered, we've had that for a long time. It's getting better and better because the IoT is getting cheaper. That same thing's happening with medicine. Like we're getting like IoT for medicine, right? You can have those watches that can measure your breaths, how much you breathe, and measure your heart rate and measure your oxygen levels. And they have those, what are those things that the PCC people have now? They stick them in their arm.
Oh yeah, the glucose monitors. Yeah, the CGM.
Right. And I can imagine more and more. They're probably not called IoT, but it's the same idea, right? It's human IoT, like devices that we wear or that we potentially could even ingest, right? There's that whole there's that whole colonoscopy thing that you just like swallow.
Yeah. Well, I mean, you think about that, like, why are there like these companies like racing to create like Apple Watch, Fitbit, the Woo thing, whatever that is? Like, there's like all these companies, like huge.
Woo thing is, I don't know what that is, but okay.
I got a Whoop strap or something, like whatever. So it's like, anyway, but like, yeah, the bootstrap, whatever. But they're all racing with billions of dollars to like try to own those markets. Why? Yeah. For the data.
Right.
Yeah. And it's like, so you think about like all of that, like, because everybody people realize that data, like if you could produce real insights to help to drive medical outcomes, which is, people's lives, stuff like that. That's huge. That's a huge market. So, I always like something Peter Diamandis says, if you want to be a billionaire, help a billion people.
Right.
And like, and your best chance is if having the best data. Yeah.
Yes, no, that's exactly right. So like those, like you said, those Fitbits and those glucose monitors and all those different things are ways to collect data about, medical data about, and then aggregating that data and be able to use that data to make decisions or to tell people things, right? To have other discoveries like, hey, we see whatever they see in that data, right? The next thing is going to be whatever, right? Whatever that could be. I don't know, but like,
yeah, I mean, it's like that. And, that's why now you're seeing like all these stuff coming out, because it's like people are kind of figuring that out, and they're realizing like, oh, these guys are profiting off of my data.
That's right.
And then all the privacy stuff coming in, and, you can't read, ChatGPT can't read my data to train models. And you get into all these kinds of debates that because they know that or was it Facebook got in trouble for selling the data? I mean, it's just, like that becomes like, people are just now coming where people realize what the value of these things were, because like in the past, it was just kind of circle back around to that. It's like, it was impossible to think about, well, there's all this data, but like, what are we going to do with it? Humans can't do that. Humans can't consume that. We got something else besides humans now.
We do. Yes, we have a way to, with that aggregated data, to look at it all as a whole and make decisions or get insights or.
Yeah. Oh yeah. It's pretty amazing.
Yeah, it is pretty crazy. It is pretty crazy. So So from a manufacturers, I think when at this conference, one of the things they talked about was like industrial AI, which is this idea of like, how does AI with your data help you make, to that point, better decisions, right? Do different things. Because we see AI like with large language models and can answer questions for us or do AI summaries, but how does that translate into manufacturing, right? And into industrial applications. And so during the conference, they were talking about that and really about, again, helping make better decisions so you can see based upon your data just for like maintenance, right? You can see like, oh, I can look at with industrial AI, I can look at like all of the data. I can say, hey, looking at the data of all these devices, and then you see like, hey, it's going to need maintenance, and then it finds the maintenance manual, and then maybe has a video from that you've recorded of like changing the part that you need, and like it finds all of that and just shows it to you to be able to do everything you need to do. So having that intelligence makes you, to your point, that much more effective, right? Because now you can, with that data, you can figure out so much more quickly like what the problem is and get it resolved, or even preventative in a preventative way.
Yeah. Oh yeah. It's phenomenal. It's just kind of like, I don't know. It's a very exciting kind of time right now. I think the next 4 years are going to be really interesting as far as like what we're able to do with it. And, and then it's going to make having, I mean, it's good. I guess it's good for us because we're in the business of making data good, right? Making data, consistent and correct and things like that, which is kind of a nice place to be. But, these systems and the data they collect are infinitely valuable in that way. So it's like, and getting it correct and being consistent about it and making sure you have that kind of stuff in place. It's a really cool time.
Yeah. So that's interesting. Is like, I was thinking about this as we were preparing for this conversation I was thinking about how if data is the asset, it's the thing that's important, then you want to think about like how you collect that data and its accuracy matters. So for companies, I would start to think about like, hey, how am I still entering this stuff manually? Am I still doing it like it was the mid 20th century, or am I looking at ways to do that better, faster, more accurate, more consistent? I would imagine that would be at the forefront of their minds now. Is things that we thought were nice to have actually become way more important if you want to leverage the data in the future, right? Because if you don't have a good process to collect it, it's not going to be any valuable to you.
Yeah. Well, it's like it goes back to like one of like the stuff with machines. I mean, if you talk about like one of the things that's nice about machines, you can get all the data about speeds and feeds, and all the sensors on the machines tell you a lot about maintenance. But like, what about the idea of the machine telling you what it's working on? Like, hey, I completed this job. This job took this much runtime. This job, if it gets a little bit nicer. I mean, lasers can kind of do that now. Like some of the laser machines, it's almost necessary because it's like it's cutting batch work. It's doing a bunch of jobs at once and things like that. So keeping track of that's can be more useful, right? But it starts getting down to where we're not relying on the operator to decide like, oh, I'm working on this or I'm working on that. It just does it, right? And then and the software can tell based on what it's working on and things like that. And the more you can kind of do that, the more consistent the data is. Not only do you have, I think about like I think about this a lot, like processes and integrations and stuff, because I'm an industrial engineer originally, and I always think about like variability in systems and stuff. And I'm like, where does the variability in this system kind of go up, right? So like if I think about software too, I'd say, okay, if I have this software handing off to this software, I don't have to do all these guard clauses and things like that to worry about like what happens if this happens or this happens, because I got software talking to software. And then we can agree on a contract, and they'll honor it, right? So it could be a little bit more loose as far as like that. It doesn't have to. You don't have to do all these like. But anytime you go to a human, essentially something that's not reliable, you have to introduce all of this guarding, all of these extra things to make sure, and put things more on guardrails to ensure that it comes out right, and that all carries an overhead to it. Mm-hmm. So if you're thinking like, well, the data is the most important thing. The data is where the asset is. We're going to build the asset up. The more and more you can take the variability out of the equation, which is, let's call it what it is, humans, right? And to put that data in, the more likely that data will have higher quality, which then the systems downstream can use to make better decisions and provide better insights, right? So like, yeah, that only is the use of the data going to become really, really helpful for these machines, but the actually of the recording of the data will become more machine driven as well.
The recording and collecting, yeah, all of that. That because everything that is involved with getting the data to a place where you can leverage it and it's accurate and consistent will be important. As I mean, this has always been true. One of the things that I think that is interesting is like the fundamentals are still the same, but you have to have good data, you have to have good information, you have to collect that information, and if you can develop a process that can do it more consistently, more quickly, and then that's all the better. So all those things still apply, but even more so now because the stakes are higher, I think, because like now it's so much easier to get insights using AI and models and those sorts of things because it can aggregate tremendous amounts of data it can learn on. Whereas before, like we always knew that it was important to have the right data and ERPs and reporting, but it wasn't always easy to get that information out, right? Like you had to write complex reports or you had to understand what you needed. And it can look at all that and just say, hey, LLM or, whoever you're talking, whoever the chat bot is, say, can you tell me about this? And having all your data and trained on it, it can aggregate that and tell you.
It can. I mean, and it's just, it's never been easier. It's never been easier, but it's never been easier to use the data, but it's all the more important to have it be right. I mean, it's never been more important to have it right too. So.
Yeah, one of the things I think that I have heard from manufacturing companies is a lot of the concern with large language models or training being used on their data and then again giving their secrets away, right? Giving away their IP or the training on the models or training on that information or their manufacturing processes. So there will be a need for, once we figure out, everybody will have their own kind of LLM, I would imagine, or there'll be each company, you wouldn't be able to just aggregate all that data into one big set, right? Because from a privacy standpoint, each company would need to train like its own model, I would think.
Well, probably it wouldn't train their own model. I think of it being like what they'll implement is probably like, and it depends on what they're doing machine learning wise, stuff like that. Like, because to train a model is incredibly expensive, right? So that's not typically like from a technical perspective, how they do it, how you would do it is what you don't want your model, you don't want your data going into the model, right? That's a valid concern because then the data is the asset, right? It goes back to that idea. But you do want your data to be in something they call a RAG type of environment, which with the RAG, what the analogy stands for, I can look it up real quick. It's essentially it's a database, like RAG definition real quick.
Right, it's that RAG format. I've heard that term before. So a bit in the weeds in terms of technical how AI works, but
yeah, for AI, it's like, so what the RAG is a retrieval augmented generation, which is like what it is that you essentially put your data into a vector database, to get really technical about that. It's easy for an LLM to reference for context, to access and get the data. So you just knowledge, you have proprietary knowledge that you're giving the models or, machine learning, whatever you're using to use to be able to reference, to then use that data to see the correlations and make suggestions, right? So do whatever it needs to do. That part that you're giving so think of like your proprietary machine that you build to do your manufacturing. Okay. And you're plugging it into the standard electricity, which is the LLM.
Right.
Okay. So your machine does what a machine does very specifically to your problem, but it all runs on electric.
Right.
And the electric is these large language models, these AI platforms that are out there that you can subscribe to like a utility.
Okay.
And that's how I predicted I think the future will be.
Right. And yeah, it makes sense that like essentially the LLM becomes like the internet, right? It's like a utility. We just use the internet and then people build stuff on top of the internet, right? They build Airbnb and Uber and Facebook and they build stuff on top of it. But essentially the internet's some kind of infrastructure. So you're seeing LLMs as infrastructure.
Yeah. And I think that's exactly what it'll be. It's infrastructure that's been trained on a lot of data. Don't get me wrong. But it's trained on the data that everybody has access. Like, because think about it, like there is no competitive advantage to like using ChatGPT in your product by itself, like, or any of these things, because everybody has it. And it's not that, right? Like it's an equal playing field at that point. The only thing that makes it valuable is how it uses your data.
Right.
Just the same way that if the only thing that like everybody can get electricity, I mean, electricity can be cheaper or better in certain places. That's why like Bitcoin mining, all that stuff matters. It looks at like those types of things. But at the end of the day, it's a utility. It's a commodity, right? But what you do with that electricity, your special machine, whatever it is you're using it for, becomes the thing.
Right. So then I think I would imagine, like companies would need, they need a strategy, a data strategy, a data collection strategy, a data validation strategy. Like they needed that strategy more so now than they ever did.
Mm-hmm. Yeah. I mean, think about every business, like not just manufacturing, but every business that has in the world, like, I mean, consulting, software,
Right.
medicine, like drugs, everything is all based on that proprietary data that you have, and so in the manufacturing world, it's all the, how do you make something and what is it you're making, and supply chain, how do you supply chain? I mean, it's like, maybe it's not just the way you manufacture it's the way you get it out you distribute it, the way you get it out to people. How do you, the special way that you package it up so it fits on trucks. I mean, like all of these things, right? There's like all of that stuff that comes together. That's part of that business, right? And then so it's it's like, how does a company take chicken and sell it for so much more than somebody else selling chicken?
Right.
Well, there's brand, and then there's the proprietary process, whatever it is. Like, that's what it is. Like KFC has their special blend of flavors for 100 years now. People still buy it. It's like, yeah, it's still, you got it. Yeah.
Yeah. So if companies, manufacturing companies, or any company, when we say like data is the strategy, it's the asset, what do they go about? How do they go about implementing that? Right. It's one thing to be on a podcast or me being at a conference and hearing about data, the criticality of data and the importance of that, and AI and how you're going to leverage that. That all sounds great. Maybe a little scary to some people, but it's like, well, how do I do that, right? What are some of the stages or the steps companies, manufacturing or otherwise, need to take to be able to use it when it's needed, when the time comes?
Yeah, I think that like anytime I try to do something new or learn it, like I always look for use cases. I think use cases are I think a lot of things with AI, they struggle from use cases, but the beauty of use cases is that it allows you as humans to draw analogies, right? And and then once you see use cases, you're like, well, that looks a lot like this other thing, and that looks a lot like this other thing, and that's another place I can use that. And then the beauty of like, especially with AI, is that you can use AI to help you think of use cases.
Right.
I mean, it's just like beautiful that way. It's just like it's such a meta tool, right? It's like, like I think we talked about a couple episodes ago, I would use AI to help me pick an ERP, right? Just based on all this stuff. So you can use AI to kind of brainstorm and help you think about how to go about doing it. You just, you're like, how do I use you better? You can ask it, right? You're like, I had this kind of data. How would you think I should use it? I mean, you actually can literally have that chat, right? You could actually do that. That's what's so cool about this technology. But like, you got to think about like use cases, and then you got to think about like, well, if I could do this, that's really similar to this other thing I need to do.
Right.
And then what data would I need to do that? Well, shoot, I should collect that. I should try to get that, all that comes, it kind of, so I was thinking like, what am I trying to accomplish? Like, what's a use case or the thing I would like to really be cool to know? And then back into how would I get the data for it if I don't already have it?
Right. Okay. So you're saying like, okay, here's a use case where I think I could use that data. It would be valuable. And then look at kind of upstream and say, how am I getting that data? Am I collecting it? How am I collecting it? What's the quality of that? Where is it going? All of those things, once you've determined the use case that you need.
Yeah, I mean, because think about like you see the one about the maintenance on machines quite often, right? I mean, that's a pretty common one you hear a lot. It's like, oh, we can predict downtimes, and because there's a lot of data, and it's a good use case, right? It's a really good use case. Like, Oh yeah, we could tell you when your machine's going to fail, and and then we could do preventative maintenance, and it's like a really good one for that. And then you say like, well, if they can, like, how are they doing that with preventive maintenance? Well, they're using these sensors. They could tell by data the fact of failure and how often they do maintenance. They have a lot of data points that can essentially predict based on certain sensors hitting certain values, and these things start to happen. But you can say, could you apply that to other things? Yeah, I mean, like what other areas of life or other areas of the world operate under similar conditions that aren't necessarily like machine making parts, but it could be like engineers designing something or coders coding something. Large systems, you have enough data, like, well, we know that takes a bug here. You can get, if there's enough, you can say, well, how do I know? How can I predict how many bugs are going to get created in every 100? Whatever that is, you could do that if you had enough data. Well, I don't have that data. Well, could I start collecting it? And if I did, how much data would I need to be able to actually start making these kind of weird predictions about things? And I think about like pricing out, like costing something that typically is very difficult to cost. Like I'm building a house, like they do it today. They could pretty much hit it. They could hit it decently. But things like they involve like highly variable things like engineer order. Like how do I get the cost prediction on engineer order even tighter? And having the systems use those to determine that. So, yeah, it's just, I think that's the way I think about it when you think about like how do I use these things or what's the next step to do it, is I always think in analogies. Think about what things you've seen, use cases, and then try to think about what's the next closest thing that looks like that, and what's keeping me from doing that thing, and what data would I need to do it, and then move again, Right. And then look at other industries. It makes you creative. It gives you ideas.
Right. Helps you to formulate like where you can use it in your business or in your life. In this case, in manufacturing or any business. Use cases, jobs to be done, and then those same things in other industries, other areas. We're like, because there's something that's applicable, similar in your area.
Right. Right. And if you can draw that analogy or you can see that variation, because there's so much of that. Like there's so much manufacturing stuff that's been ported to software design. All the time. It's like they even call it like there's even a thing in software called Kanban,
right?
Which comes from like the Toyota production system. Like all of these things, because somebody saw a good idea and they're like, that's a little bit like this, and I can use that process over here and just copy it and apply it to a completely different domain. People, that's what's called creativity,
right? No,
I mean, steal from here and use it over here. That's creativity right there. I mean,
yeah, that's true.
It's like.
That reminds me, there's this quote in Latin that translates nothing new under the sun, which is like there's no new ideas. To your point, it's like, hey, that looks like this, and you just take that analogy and you apply it over to the next thing. And so it's a good way to see, right? It's like look at what you're doing and what is that similar to, and then start from there.
Exactly.
So I guess some key takeaways from this. One key takeaway is like the data is more than just a job to be. It's just like more than just a job, right? It's actually the strategic business asset. The strategic business decisions helps you make this business decisions, and the need to create a data strategy going to be more important than ever, because that's going to help more inform the business and make better decisions in the future, even more so than it ever used to.
Absolutely.
So I guess if you're a business, you're thinking about, like, I would say, hey, to your point, how am I collecting the data? Or am I collecting the data? How good is it? How am I collecting it? How can I make it better? What's that strategy look like? And then set up the systems to make it happen. Or to look at your use cases as well and say, okay, where I think I can apply this, and make sure that you're collecting the data in the cleanest, fastest, easiest way possible, so you can get those consistencies.
There you go.
Okay. Yeah, I think, just continue to learn about the value of that data, right? And different how large language models work and how they use the data. Having some of that knowledge will help you once you're looking at your data strategy, and what data you want to collect from a manufacturing standpoint. What data from engineering, what data from ERP, what data from the shop floor. You'll be able to figure that out by using, as you said, the jobs to be done, things you want to learn about your business from that data.
Exactly. Yeah.
Okay. Well, Scott, this is a good discussion. I think another discussion about AI. Like I said, I was at this conference and industrial AI came up, and the importance of data and the quality and all of that mattered. Right. That was a big part of the conversation. And this particular ERP certainly was talking about leveraging that AI in the system. And I think even someone mentioned on stage today or yesterday was like the importance of that data strategy, right? Like you got to have a way to get it into a platform, a way that can be digested and can be used.
Yep, exactly right.
Okay, Scott. Well, that's another good episode. I enjoyed this conversation, even though I'm a bit run down from the weeks of efforts. So tomorrow I'll be back on a plane coming back to the United States. But look forward to our conversation next week. And anything else you left to add before we say goodbye to the audience?
No, just have a safe trip home and enjoy the last bit of Europe there until you go back again. And then, anybody who's out there and you're at a show and you happen to see Jeff or Frank, say hi while you're out there. The rest of the guys, we travel all over the world. I don't get to travel as much, but the guys do, and I think they always appreciate when you come up and you say hi.
Yeah, thanks, Scott. Thanks, everybody. Feel free to visit us on our website at cattalk.com and learn more about our blog. You'll find some more information about AI and about data governance in the blog. And of course, like and share this video and subscribe to our podcast. Everybody, you have a good night.
Thanks, everyone.